Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Dear students, this second video lecture of week 7th for the course Biostatistics 1 is the continuation of my previous first video lecture of week 7th. In the first video lecture, we have already learned about the measure of dispersion. And dear students, I have already told you in the previous video lecture that we can calculate the amount of dispersion by coefficient of range, by coefficient of quartile deviation, and by coefficient of mean deviation and coefficient of variation. So in the previous video lecture we have already learned about the coefficient of range and coefficient of quartile deviation. Now in this second video lecture, today we are going to learn about the coefficient of mean deviation and coefficient of variation. So first of all, I would like to tell you about the mean deviation. Dear students, we can calculate the mean deviation from mean and from median. So mean deviation is the arithmetic mean of the deviation of a series computed from any measure of central tendency. That is the mean, median, and or mode. All the deviations are taken as positive, that is, signs are ignored. Symbolically, it can be written as MD, mean deviation, is equal to sigma absolute xi minus x bar divided by n. And this is mean deviation from mean for ungrouped data. And mean deviation is equal to sigma fi into absolute xi minus x bar divided by n, and this formula is for the group data. In this formula, dear student, you see over here, this capital N represent sigma f, and this small n represent the total number of terms in the data, and xi represent each individual of the data, and x bar represent the mean of the data. So dear students, we can find the mean deviation from mean and from median or from mode. So in this video lecture, we will learn about the mean deviation from mean and from median.
Mean deviation according to median. Mean deviation according to median sigma xi minus md divided by n for ungrouped data, and md is equal to sigma fi into xi minus md whole divided by n for the group data. Similarly, we can find the coefficients of mean deviations. Relative mean deviations is obtained by dividing the mean deviations by the range used for the calculating mean deviations. So coefficients of mean deviation is equal to mean deviations divided by mean or median or mode. For example, we have ungrouped data. To calculate the mean deviations according to mean and according to median for this data: 45, 32, 37, 46, 39, 36, 41, 48, and 36. And also we need to calculate coefficients of mean deviations. First of all, find mean deviations according to mean and according to median. Then we can easily calculate the coefficients of mean deviations according to mean or according to median or according to mode. So arrange the data in ascending order. You see over here, first of all, arrange the data, but for the mean, arrangement of data is not necessary. For the median, arrangement of data is necessary in ascending order. So first of all, arrange the data: 32, 60, 36, 36, 37, 39, 41, 45, 46, 48. So the mean of the data, sum of all terms divided by number of terms, and we have already discussed in the previous video lectures how to find the mean and the median. These are actually called the central tendency. So sum of all terms is 360 divided by 9, and now the mean is 40. So mean deviations is equal to median. Marks obtained by n plus 1 divided by 2, the students in order data. So median, marks obtained by 9 plus 1 by our 2, 10. by 2. Fifth, marks obtained by n plus 2 students in order data, marks obtained by the fifth students in order data, which is equal to 39. At the fifth position, 1, 2, 3, 4, 5. At the fifth position, we obtained 39. So mean for this data is 40 and median is 39. Now we can calculate other results according to mean or according to median. And you see over here in this table, this table is very interesting. Right in the first column, the values of the data, and then subtract each individual from the mean if we calculate the mean deviation according to mean. Then subtract all individuals from the mean results and put each result absolutely. Ignore the negative sign. You see over here in the first column there are some negative sign, but ignore the negative signs. Absolutely subtraction of x bar minus xi. X bar minus xi mean subtract the mean result from each individual results. So mean is 40, 40 minus 32, 8, 40 minus 36, 4, 40 minus 36 again 4, and so on. Now if we need to find the mean deviation according to median, then subtract absolutely median from the each individuals. Since median is 39, so 39 minus 32, 7, 39 minus 33, 6, 39 minus 36, 3, 39 minus 37 equal to 2, 39 minus 39 equal to 0. So these are the difference of each individuals and mean, and these are the absolute difference. These are the difference of absolute difference of median in each individuals. So if we want to calculate the mean deviations according to median from this ungrouped data, you see over here sigma of this class, sigma of this column, sigma of this column is 40, and the number of values in the data are 9, so 4.9 is the mean deviations according to mean. Now according to median mean deviations, uh, sigma of this column you see over here, sigma of this column is 39 divided by n, 39 by 9, 4.3. Now the coefficients of mean deviations divided by mean or median or mod. So mean deviation 4.4 divided by 40 according to mean, and according to median 4.3 divided by 39. So the mean deviation coefficient is 0.11. So the data is a consistent data because the amount of dispersion is less. Now to find the mean deviations from the median from the following group data in the first age in year 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. And the number of persons represent the frequency of each class. And dear students, these are the continuous data because the first class end at 10 and the second class start at also at 10. So these are the continuous boundary. 0 to 10 and 10 to 20. So these are the continuous classes. So we don't need the real class boundary. So first of all, construct the table. In the first column, write the classes, and the second column, write the frequencies. Now construct the cumulative frequency column because we need median. For the median, we need the cumulative frequencies. Now midpoint of each class. Subtract these two boundary divided by 2, subtract these add these two boundary divided by 2, add these two boundary divided by 2, add these two boundary 50, 50 divided by 2, 25. Now since we need mean deviation according to median, first of all find the median. In this data the total terms is 204. 204 is even, so 204 n divided by 2, the median position is 102, and 102 lies in this cumulative frequency group. 102 lies in here. So in this class median lies. First of all calculate the median. So median lies in this class, and the class size of this of each class is 10. The frequency for this class is 40, and the cumulative frequency for this class is 77. Now putting the values in this formula, L plus H by F into n minus 2 divided by C. The lower limit of the class at which median lies 30 plus class size 10, frequency 40, total terms 10. Total terms is 204 divided by 2, which is equal to 102, and the cumulative frequency is 77. Now after simplifications we obtain median 30 plus 6.25, which is equal to 36.5. So 36.5 is the median of the group data. Now subtract median from each this x. This x now represent the midpoint of each class. Now subtract the median from these classes and ignore the negative sign. You see over here this absolute sign mean ignore the negative sign. And now multiplied this results to the frequency. You will obtain frequency multiplied x minus median. But if we need mean deviations according to mean, then first of all find the mean and then subtract mean from each individual and then multiply it from each individual. Individual mean the midpoint of each classes. So median from each x multiplied by x, you see over here we obtain a new column. Now the sigma of this column, the sum of this column is 2885. So the mean deviations according to mean deviation according to median in group formula. You see over here this is the formula of mean deviations according to median in group form. Sigma fi into xi minus md absolute divided by total terms. So sigma of f into xi minus md denoted 2885. So 2885 divided by 204, which is 14.14. Now the coefficient of mean deviations. Mean deviation divided by median. We obtain median is 36.5 and mean deviation 14.14, which is equal to 0.387. Now another method by which we can calculate the amount of dispersion called variance and standard deviations. Variance. The variance of a set of observations is defined as the mean of the square of all the observations from their mean. When it is calculated from the entire population, the variance is called the population variance, traditionally denoted by sigma square. Rho square, denoted by rho square. If instead the data from the sample are used to calculate the variance, it is refers to a sample variance and is denoted by S square. In order to distinguish between the two, the symbolic definition of variance is a rho square is equal to sigma of xi minus mu whole square divided by n for population data, and rho square is equal to sigma fi into xi minus mu whole square divided by sigma fi for group data. And similarly for the sample case, s square is equal to sigma xi minus x bar whole square divided by n for ungrouped data, and s square is equal to sigma fi into xi minus x bar whole square divided by sigma fi for group data. So dear student, these two formula represent the variance for populations, for in case of population, for ungrouped data and for group data. And these are the formula of variance in case of group data, but for sampling. These are the variance formula for variance in ungrouped data, but for sample. And these are the variance formula for group data for a sample. In these two formula represent the variance for populations in case of ungrouped data and in case of group data. And these are the two formula in case of group for the sample. These are the formula for ungroup and this is the formula for group in case of sampling. So in case of populations, the variance calculated by this formula in case of ungroup, and in case of group data, variance calculated by this formula. Similarly, for the sampling, variance calculated for ungrouped data by this formula, and for the group data we use this formula. Now the standard deviations. The positive square root of the variance is called standard deviations. Symbolically, it can be written as rho under root sigma into xi minus mu whole square divided by n for ungrouped data, and sigma is equal to under root sigma fi into xi minus mu whole square divided by sigma fi for group data. And similarly, in case of sampling, S is equal to under root sigma xi minus x bar whole square divided by n for ungrouped data, and S is equal to under root sigma fi xi minus x bar whole square divided by sigma fi for group data. And the coefficient of variance, the variability of two or more than two sets of data cannot be compared unless we have a relative measure of dispersion. For this purpose, current persons introduce a relative measure of variations known as the coefficient of variation, abbreviations C.V. Coefficient of variations, symbolically it is defined as coefficient of variation is equal to S divided by S bar multiplied 100 for the sample data, and coefficient of variation is equal to rho divided by mu multiplied 100 for the population data. Suppose we have an example to calculate the variance and standard deviation for the group data 14, 22, 9, 15, 20, 17, 12, 11, and also calculate the coefficients of variations. You see over here, first of all, construct the table, and the first column write the individual's values, and now find the mean. Sum of all terms divided by number of terms. Sum of all terms is 120 and number of terms is 8, so mean is 15. Now subtract mean from each terms and ignore the negative sign. But since we take square here, so if we don't ignore the negative sign by the square, definitely negative sign will be changed into positive. So x minus x bar, each x I minus x bar whole square, you see over here, obtain this column. Now the sigma of this column, sigma x I minus x bar whole square divided by n, 140 divided by 8. So the variance for this sample is equal to 17.5. And now the standard deviations, taking square root on both sides, the standard deviation is 4.18. This is the standard deviation for the sample data in ungrouped form. So the coefficient of variance is S divided by x bar. S means the variance divided by 100. And variance is S means standard deviation. Standard deviation is 4.18 divided by mean 15 multiplied 100, 27.86%. Now to calculate the variance and standard deviations in the form of group data, you see over here, this is the previous examples. This is the continuous data, and these are the frequencies of the data. So first of all, calculate the mean. For the mean, you see over here in the next column, in the next, first of all, write the frequencies, construct the table. These are the classes, these are the frequencies, these column represent the x. Now multiplied each frequency with the x. How obtain the x? Find the midpoint of each class. You obtain x. Now f and x multiplied, construct this column. Now find the mean sigma fx. Sigma of fx is 140, and 140 sigma of fx, sigma of fx is 5550, and sigma of fx 5550 divided by sigma f 140, so the mean is 39.64. Now subtract all xi from the mean, subtract mean from xi, and taking the square and then multiplying the square column with the frequency, you will obtain this new column. And now the sigma of this column is 33,677.058. Now putting all these values, sigma of fi into xi minus x bar whole square divided by sigma fi, 36,677.058 divided by 140, you see over here in this slide. So this is the variance, 240.55. Now the standard deviation, taking square root of 240.55 is equal to 15.5. And now the coefficient of variance, standard deviations multiplied by mean, standard deviation divided by mean multiplied 100, and this is equal to standard deviation 15.5 divided by mean multiplied 100, 39.10%. So dear students, in this lecture you see over here the conclusion of this lecture, how to calculate the amount of the amount of dispersion. Dispersion actually the spreadness show the spreadness of the data, show the consistency of consistent amount of data. Data will be consistent if the dispersion is less than the dispersion of the other data. Then data called consistent data. So dispersion mean the amount of spreadness. So if when we compare two data and the dispersion amount of one data is less than to the dispersion of other data, then the data will be more consistent as compared to the other data. And how we can find the dispersion? We can find the dispersion by range measurement, coefficient of range, by mean deviations according to mean, according to median, and coefficients of mean deviations by variance and by standard deviations. And now this is the end of this segment. Thank you. Allah Hafiz.